Hello, Natalie Tarry here from Natematics. I'm here to take you through a question on circles and angles and lines. So yeah, it's a circle theorem question. This is something that is applicable for higher level GCSE and also for intermediate level at if you're doing WJEC maths. So that's under the Welsh Examination Board. So normally on a lot of the things I do, I tend to approach it like an exam question and say, well, what's in front of you? What maths have you learnt on it? What rules are important, etc., etc. Now, I'm just going to go at this as if it's, well, we know it's circle theorems. We know there's a circle. We know there is, well, what else can we see? Well, we can see a triangle. We've got a triangle here. Highlighter pens are fab for this sort of thing. We can also see a couple of quadrilaterals here. There's another one here, and I'll highlight some of these as they come along. We've got a tangent. We've got the centre marked, and you've got a line coming from the centre, radius. The radius meets the tangent. That could be quite useful later on. So what I suggest we do then is when we are coming to do one of the questions is, well, highlight the area that we are interested in. So to find angle ABC, well, actually, where is it? What is it part of? And maybe it might be part of something where we already know an angle, but equally, it could also mean that we have to find another angle before we can find that one out. So just be aware of that. If you can't think, oh, I can't find it straight away, that's okay. You might just need to work something else out first. So look at what you know and what can we find out. So ABC is part of this quadrilateral here. Okay, so it's about looking for quadrilateral, maybe there's a triangle, maybe, who knows? I'm going to record a few of these so you can go through them. Now, what do you know about a quadrilateral that's in a circle? It's called a special type of quadrilateral, and it's a cyclic quadrilateral. So, and we do know that in a cyclic quadrilateral, opposite angles add to 180 degrees. That's a rule, you've just got to know it and just remember it. So that means that this angle here and this angle here adds to 180. So therefore I can work out that angle there as being 112 degrees. You can do the maths afterwards. So those two add up to 180. Excellent. We can give that one a tick. So we've done that one. Okay, so the next thing is find angle AOC. Well, where is that? Well, that's here. So it's the angle in the middle here. So it's formed, remember, angles are always formed by two lines that are rotated. So one's come away from the other and rotated away from it. So let's have a look at what we've got here then. So I've got this angle here that comes around the centre. And I've also got an angle here that comes from exactly the same chord. So the AC is a chord. We've got an angle coming from it here. Subtended is the sort of mathematical word. And we've also got this angle subtended here as well, but it touches the circumference. So what do we know about that rule? So the angle at the circumference is half that at the centre, especially when they come from the same chord. So therefore, this is 68. This is half this angle. So turning that around, this angle must be double 68, so 136. Okay, about recognizing those patterns there. Right, next rule. Find CAE. So CAE. So we're going to highlight that. So it's that angle there. Okay, what is it part of? Well, it's touching the tangent. Now, what do we know about angles that touch tangents? What circle theorems come up in relation to those? Well, we do know that that's a sort of a minor segment, isn't there? There's a minor segment here. And then we've also got the alternate segment. So the angle, is there an angle coming off this chord and hits the circumference, just out of interest? Ah, yes, we have. We've got this one, haven't we? So is this not angles in an alternate segment? because you've got a chord here that hits the tangent. That's that angle. Anything that comes off this same chord and hits the circumference is the same as this one. So therefore, this is 68 degrees. How we remember these really is practice. The more questions you do, the more you identify these angles and the patterns in them. So if circle theorems is something that you struggle with, and it is something that quite a lot of people do struggle with, practice, practice, practice. I highly recommend you just do loads of questions of different patterns, ideally not in sections that say, oh, these are alternate segment questions. These are radius hits the tangent at a right angle questions. You know, have them all mixed up, because it really then does help you to think a little bit more. So thank you very much, and thank you for watching. Bye-bye.